Hi folks, today I have another reaction for you which is oxidation and reduction. So I have two instead of one. In oxidation reaction, we're going to look at that first and then we're going to look at the reduction reaction. So oxidation reaction right here and then we're going to look at the reduction reaction down here. All right, so in an oxidation reaction, bonds between carbon and oxygen increase. So number of bonds between the carbon atom and the oxygen atom in the molecule will increase, and the bonds between carbon and hydrogen are reduced. And that is an oxidation reaction. So that is a general definition for organic chemistry, what an oxidation reaction is. An oxidizing agent will usually be labeled as a square bracket with the oxygen in the middle, representing an oxidizing agent, or KMNO4, or K2CR2O4. So these are the common oxidizing agents. Sometimes when they give you a question, they will omit everything from it. So they will not represent anything. They will not have anything indicating that it is an oxidation reaction. They will only tell you that the substance is being oxidized. And so that is a way of asking a question as well. Now, when a substance is oxidized, it can result in production of different products. For example, when a primary alcohol has one bond between the carbon and the oxygen, because it's an OH group attached to the carbon chain. So when a primary alcohol, which means the alcohol or the hydroxyl group is on the end of the molecule, undergoes an oxidation reaction, it will increase the bond between the oxygen and the carbon. So instead of now the carbon single bonded to the hydroxyl group, the carbon will be double bonded to the oxygen at the end of the molecule. When a carbon is double bonded to the oxygen, carbonyl group, is at the end of the molecule, we make an aldehyde. So in other words, when a primary alcohol undergoes an oxidation reaction, it will result in the production of an aldehyde. Alcohol having carbon single bonded to the OH, so carbon single bonded to the OH, and now we are taking the same carbon and now we are double bonding to the oxygen. And because oxygen has a bonding capacity of 2, the hydrogen has to be let gone. So the hydrogen will leave. So the carbon is now double bonded to the oxygen. Now, the aldehyde can undergo oxidation reaction as well. Now, when an aldehyde will undergo an oxidation reaction, we cannot create carbon to oxygen triple bond, but we can increase the bonds between carbon and the oxygen by having a hydroxyl group. So now the carbon at the end of the molecule is attached to a hydroxyl group and a carbonyl group. And in other words, what we have just done is we have made from an aldehyde by an oxidation reaction into a carboxylic acid. So we have a carboxylic acid that we have made. So a primary alcohol can become an aldehyde by undergoing an oxidation reaction, and an aldehyde can undergo oxidation reaction to form a carboxylic acid. Let's look at the secondary alcohol. Now, in the secondary alcohol, and I can draw an example at the bottom, we have the hydroxyl group attached to a carbon in the middle of the molecule. When the secondary alcohol will undergo an oxidation reaction, the carbon or carbonyl group will be located in the middle of the molecule. And the family which has a carbonyl group in the middle of the molecule is called a ketone. So a secondary alcohol undergoing oxidation reaction results in the production of a ketone, not an aldehyde. Right? I hope this makes sense. Primary alcohol, the hydroxyl group is at the end of the molecule, and when it undergoes oxidation, produces an aldehyde. But a secondary alcohol, because the hydroxyl group is located in the middle of the carbon chain, somewhere in the middle, not at the ends, it will form a carbon to oxygen double bond in the middle, somewhere in the of the molecule, which will result in the production of a ketone. Now, carbon in the middle already it has a bonding capacity of 4, and it has already used the 4 bonding capacity. The carbon is bonded on the left hand side to a carbon, right hand side to the carbon, and it's also double bonded to the oxygen. This ketone cannot be further oxidized because we cannot add a hydroxyl group to the carbon in the middle, because the carbon-carbon bonds are very strong, and now we have a carbon double bond to the oxygen, and we cannot increase the number of bonds between carbon and oxygen by attaching a hydroxyl group and breaking the bonding capacity rule. And therefore, in this case, ketone cannot be further oxidized. So over here, we will have a no reaction. So a primary alcohol, reiterating, is a primary alcohol can undergo an oxidation reaction to form an aldehyde. An aldehyde can undergo an oxidation reaction to form a carboxylic acid. A secondary alcohol undergoing an oxidation reaction will form a ketone, but it cannot be further oxidized. And tertiary alcohol means the carbon is connected on the left, on the right, on the top, and with the hydroxyl group, for example, and we have a carbon chain at the bottom as well. Carbon-carbon bonds are strong, so those are not going to break. And if a tertiary alcohol tries to undergo an oxidation reaction, we will have to create a carbon to oxygen double bond, which is not possible because the carbon's bonding capacity is 4. It has already used 3 of these bonds to attach to other carbons, which are really, really strong bonds, not going to break here. And keeping those 3 bonds, we cannot add another 2 bonds to attach to the oxygen. So a tertiary alcohol will not undergo an oxidation reaction and therefore will not produce any new products. And that is an oxidation reaction for alcohols, for example. So primary alcohol undergoing oxidation, secondary alcohol undergoing oxidation, and a tertiary alcohol undergoing under oxidation reaction. We can also reverse the reaction and look at the reduction reaction. In the reduction reaction, bonds between the carbon and the oxygen atoms are decreased, and or the bonds between the carbon and the hydrogen atoms are increased in a molecule. Common reducing agents are, again, you will see them represented with a square bracket and H in the middle, or LiAlO4. These are the commonly used reducing agents, and if you see them on the left hand side of the equation, they mean this reaction is going to undergo a reduction reaction. All right. Now, as I said, reduction reaction is very similar to the oxidation reaction in the opposite way. So, carboxylic acid, when it undergoes a reduction reaction, a carboxylic acid with the carbon double bonded to the oxygen and single bonded to the hydroxyl group will lose or reduce the number of bonds between the carbon and the oxygen. So carboxylic acid undergoing an reduction reaction will produce an aldehyde, and because the aldehyde will have a carbon double bond to the oxygen and you will have attached to the carbon chain, we have lost one bond between carbon and the oxygen. And an aldehyde can undergo a reduction again and become a primary alcohol, right? So we will have, because the carbon is bonded to the oxygen at the end of the molecule, and therefore it can form a primary alcohol. Similarly, a ketone can undergo a reduction reaction and form a secondary alcohol. And I can show you an example here. Let's say a ketone, we have carbon, and we have carbon double bond to the oxygen and single bond to the carbon. So the carbonyl group is in the middle of the molecule somewhere, and when it undergoes a reduction reaction, we will reduce the number of bonds between the carbon and the oxygen. So instead of a double bond, it will become a single bond. And now we see we have just formed a secondary alcohol, right? This secondary alcohol can again further undergo a reduction reaction and lose that one single bond that it has with the carbon, and it can form an alkane with no bonds to the oxygen. So, reviewing, oxidation reaction and the reduction reaction are opposites of one another. In an oxidation reaction, a primary alcohol becomes an aldehyde, and an aldehyde undergoing oxidation reaction can become a carboxylic acid. A secondary alcohol undergoing oxidation produces a ketone, but a ketone cannot further undergo an oxidation reaction because the carbon double bond to the oxygen is somewhere in the middle of the molecule. And tertiary alcohols do not undergo an oxidation reaction. Same way, looking at the reduction, a carboxylic acid can undergo a reduction reaction to form an aldehyde, and an aldehyde can undergo a reduction reaction to form a primary alcohol. In the second case, if you have a ketone can undergo a reduction reaction to form a secondary alcohol, and a secondary alcohol can undergo a reduction reaction to form an alkane. I hope this helps to clarify the two reactions, the oxidation reaction and the reduction reaction. If you have questions, feel free to comment below, and please like and subscribe